It's kind of amazing how much AI is just part of our lives now.
Oh,
Sometimes you
yeah.
barely notice it, right?
Yeah.
Phone assistants and things.
Totally. And then you hear about these almost sci-fi concepts, these really advanced intelligences maybe coming down the line.
Exactly. So, okay, let's unpack this a bit because we're doing a deep dive today into the main categories of AI.
It feels important to get clear on the terminology.
It really is. Understanding these different types helps make sense of what AI can do now and, where it might be heading. It gives us a framework.
Couldn't agree more. So we're planning to break down machine learning first.
Yep.
Then we'll get into deep learning. After that, narrow AI, the stuff we use every day.
Right.
And then look a bit further ahead at general AI. And finally, the really big one, super intelligent AI.
Sounds like a good plan.
Yeah, the goal here is really just to give you, the listener, a clearer picture of what these different labels actually mean.
Maybe why making these distinctions is actually useful, especially as AI keeps developing so quickly. Okay, let's kick off with machine learning. ML, right? That's the common term.
That's the one.
The core idea, as I understand it, is that instead of coding every single rule, you give the computer data and it learns from it.
Exactly. Think about teaching a child, maybe, to spot a cat. You don't list rules like pointy ears and D whiskers and D fluffy tail equals cat.
Huh, right. You just show them lots of pictures of cats.
Precisely. And eventually, they just get what makes a cat a cat. ML works a bit like that, finding patterns in data without explicit instructions for every pattern.
So the AI figures out its own rules based on the examples it sees.
That's the key shift. It adapts. It improves on a task over time as it gets more data, rather than just running the same fixed program.
And we see this, well, everywhere, basically, like spam filters in email.
Classic example. They learn what looks like spam because you, or lots of users, have marked similar emails as spam before. That's using labeled data.
Ah, okay, so labeled means the data comes with the answer already attached, like
Yeah.
this is spam, this isn't.
You got it. That's called supervised learning. Or think about when you're shopping online and it suggests things you might want to buy.
Yeah, sometimes creepily accurately.
Well, that's ML again. Predicting what you might like based on what you've looked at or bought before, it learns your patterns.
That adaptability is huge. It's not just static software.
Not at all. It personalizes things, makes experiences feel tailored, which, old school software just couldn't do at scale.
Now, you mentioned supervised learning. Are there other ways machine learning learns?
Oh, absolutely. Supervised learning needs those labels, those right answers, but then there's unsupervised learning.
Okay.
That's where the AI gets data without any labels. It just looks for patterns, for structure, for maybe natural groupings within the data itself.
So like finding hidden connections we didn't know were there.
Kind of. Imagine feeding it customer purchase histories, and it might automatically sort customers into different types based on buying habits without being told what types to look for. It discovers the segments.
Interesting. Okay, supervised, unsupervised.
Yeah.
And there's one more, right? Reinforcement learning. That one sounds active.
It really is. Reinforcement learning is all about learning through trial and error. An AI agent, like a robot or a game playing program, tries things out in an environment.
And gets feedback.
Exactly. It takes an action, gets a reward if it did something good towards its goal, or maybe a penalty if it did something bad. A bit like training a pet, in a way.
So it gradually figures out the best strategy, like learning to play a video game really well by just playing it a lot.
Perfect example.
Mm.
Or a robot learning to walk by, trying different movements and getting rewarded for staying upright and moving forward.
Wow. Okay, so ML covers a lot. Spam filters, recommendations, even game playing AI. It
Yeah.
really feels like the bedrock of modern AI.
It absolutely is. It's that foundational layer enabling so much of what we see.
Right, got a handle on machine learning. Let's move to deep learning then. This term pops up all the time, especially with the really impressive AI stuff. How does it connect to ML?
Okay, so deep learning isn't separate from machine learning. It's actually a subset of it. A very powerful, specific kind of machine learning.
Okay. A subset. So
Yeah.
what makes it deep?
Good question. The deep part refers to the structure of the artificial neural networks it uses. Think of them as being inspired by the brain's interconnected neurons.
Neural networks, right?
Yeah, but instead of maybe just one or a few layers of these neurons, like in some older ML techniques, deep learning uses networks with many layers, sometimes dozens, even hundreds. Deep layers.
Okay, more layers.
Yeah.
Deeper networks. What's the advantage of having all those layers?
Well, that depth lets the network learn patterns in data in a kind of hierarchical way. It can automatically figure out really complex features, especially from raw, messy data like images or sound.
Hierarchical, what do you mean by that?
So imagine it's looking at a picture. The first few layers might learn to spot simple things, like edges or corners.
Okay.
Deeper layers then combine those simple features to recognize slightly more complex things, like shapes or textures. And then even deeper layers combine those to recognize objects, like a face or a car or a cat. It builds up understanding layer by layer.
That sounds incredibly powerful. Much more sophisticated than just looking for simple patterns.
It is. And that's why deep learning is so good at tasks that were really hard for older AI, like understanding images or recognizing speech or processing natural language.
Can you give some examples where deep learning is really making a difference?
Sure, facial recognition on your phone, that's often deep learning.
Right, unlocking my phone.
Yep. Those voice assistants, Siri, Alexa, Google Assistant, understanding what you say and responding. Deep learning is key for both the speech recognition and understanding the meaning. And, those really advanced AI models that can write surprisingly human-like text or translate languages almost instantly or even generate computer code.
Yeah, those are amazing.
That's deep learning too. Large language models, they're called. They rely heavily on these deep neural network architectures.
So it excels with that unstructured, complex data, images, audio, text stuff that's hard to define with simple rules.
Precisely. But there's a trade-off. This power needs two things. Usually vast amounts of training data
There are lots of examples.
and serious computing power to actually train these huge, deep networks. It's computationally expensive.
That makes total sense. Processing all that data through all those layers must take a lot of horsepower. So is deep learning why AI seems to have taken such big leaps recently? Why it sometimes feels almost magical?
I'd say it's a huge part of it, yes. Its success in areas like computer vision and language has really driven a lot of the recent progress and the public perception of AI advancing rapidly.
Okay, fascinating.
Heck.
So we've got machine learning as the base. Deep learning is this powerful, multi-layered subset. Now let's shift gears to the AI we probably interact with most without even thinking about it. Narrow AI.
Right, ANI or artificial narrow intelligence. This is basically all the AI that exists and is deployed in the world today.
And the key thing here is it's narrow, specialized.
Exactly. It's AI that's designed and trained for one specific task or a very limited set of tasks. It might be incredibly good at that one thing, maybe even better than humans.
But only that one thing.
Precisely. Think of it like an expert tool. A calculator is amazing at math, but you can't ask it for driving directions. And narrow AI is like that, highly skilled, but within strict boundaries.
Give us some common examples then.
Well, we mentioned voice assistants. They understand commands, set timers, play music. That's narrow AI.
Yeah.
Recommendation engines, Netflix suggesting movies, Amazon suggesting products. That's narrow AI predicting preferences within its domain. Even, say, a robot vacuum cleaner navigating your living room, or the software that filters spam, or AI used in playing chess or Go at superhuman levels. All narrow AI.
So they're performing these tasks really well, but they don't have any general understanding or ability to, transfer their skills.
Not at all. The chess program can't suddenly decide to write poetry. The recommendation engine can't diagnose a medical condition. They are locked into their specific training and purpose. They lack common sense or broad cognitive abilities.
It's kind of wild to think that pretty much all the AI we encounter daily falls into this narrow category, even if it feels quite smart in its niche.
That's a really important point to grasp. Narrow AI is everywhere, quietly making things work better, solving specific problems. It's the workhorse of the AI world right now.
Okay, that clarifies the present. Now let's gaze into the crystal ball a bit and talk about general AI. This sounds like the next big step, right? AGI.
It really does. Artificial General Intelligence, or AGI, is sort of the benchmark often seen in, more speculative discussions. It refers to AI that has human-like cognitive abilities.
Meaning, it could do anything a human brain can do. Learn any task.
Well, that's the idea. And AGI wouldn't be limited to just one thing. It could theoretically learn, understand, reason, and apply its intelligence across a vast range of different tasks and domains, much like we humans can switch between writing, solving problems, having conversations, being creative.
So real flexibility and adaptability. Not just pre-programmed skills, but the ability to learn new skills, figure things out independently.
Exactly. True cognitive flexibility. The ability to generalize knowledge from one area and apply it somewhere else. That's the core concept of AGI.
Wow. That sounds revolutionary. But you said speculative. Where are we actually with AGI? Is it close?
Not really, no. AGI is still very much a research goal, a long-term one. We've made huge strides in narrow AI, as we discussed, but achieving that kind of general flexible intelligence is a whole different ballgame. There are massive scientific and engineering hurdles still to overcome. We don't fully understand how our own general intelligence works yet, let alone how to build it artificially.
So it's an aspiration, something researchers are working towards, but definitely not something you can buy off the shelf or even expect next year.
Correct. It's firmly in the realm of research and development.
But if we ever got there, I mean, the potential impact seems enormous.
Oh, absolutely. It's hard to even overstate it. And AGI could potentially accelerate scientific discovery at an unbelievable rate, finding cures for diseases, maybe solving climate change, exploring space. Its ability to tackle complex, multifaceted problems could change everything.
Yeah, it's mind-boggling to think about. Exciting, but maybe a little intimidating too.
Understandably so.
Okay, so that's the potential future of AGI. Now let's go one step further into territory that really feels like science fiction. Superintelligent AI, ASI.
Right. If AGI is AI as smart as humans, ASI, or artificial superintelligence, is AI that is significantly smarter than humans across the board.
Smarter in what way? Just faster.
Not just faster, though almost certainly that too, but smarter in terms of intellectual capability, problem-solving, creativity, social intelligence, general wisdom, an intellect that surpasses the best human brains in basically every field.
That's hard to even imagine.
Yeah.
An intelligence fundamentally superior to ours.
It is. Think about the gap between, say, human intelligence and chimpanzee intelligence. ASI would represent a similar or potentially vastly greater leap beyond human intelligence.
What could something like that even do?
Well, theoretically, an ASI could solve problems we currently consider impossible. It might invent technologies we can't conceive of, unlock mysteries of the universe, maybe even address fundamental questions about existence. Its capabilities are, by definition, beyond our current comprehension.
And this is where the really serious ethical questions and, frankly, anxieties come in, isn't it? The control problem, alignment.
Absolutely. The prospect of creating something vastly more intelligent than ourselves raises profound ethical and safety concerns. How do you ensure its goals remain aligned with human well-being? How do you control something potentially uncontrollable? These are huge debates in the field.
It's the stuff of countless sci-fi movies, often cautionary tales. So, just to be crystal clear, ASI, does it exist? Is it even remotely close?
No, absolutely not. ASI is purely hypothetical at this point. We have zero examples. It's a theoretical possibility way down the line, if we even get past AGI first, which is itself a massive challenge.
Okay, so it's important to keep that perspective. It's a fascinating what if,
Yeah.
but firmly in the what if category for now.
Exactly. But thinking about that what if is still valuable. It encourages us to be thoughtful and proactive about the direction AI development is taking, even with the narrow AI we have today. Considering the long-term possibilities helps frame the near-term choices.
That makes a lot of sense. Well, this has been incredibly clarifying. Just to run through it one last time. We started with machine learning, AI, learning from data, the foundation.
Check.
Then deep learning, that powerful subset using deep neural nets for complex stuff like images and language.
Yep, the driver of recent breakthroughs.
The narrow AI, the specialist AI we use every single day, great at specific tasks, but limited.
The current reality.
Then we looked ahead to general AI, or AGI, the goal of human-level flexible intelligence, still very much a research project.
The ambitious future target.
And finally, superintelligent AI, ASI, the hypothetical intelligence, far surpassing humans, raising big questions for the distant future.
The ultimate theoretical endpoint for now.
It really highlights the spectrum, doesn't it? From the practical tools improving our lives now to these really profound future possibilities.
It really does. And understanding that spectrum is key to having informed conversations about AI, its benefits, and, the challenges, too.
Absolutely. It's just undeniable how AI is already reshaping things, and thinking about where it could go is, well, it's quite something. We're definitely just at the beginning of this journey.
For sure. It's a field that's constantly evolving, bringing huge opportunities, but also needing careful consideration. It makes discussions like this really important.
Couldn't agree more. And hey, if you listening have thoughts on any of this or want us to explore one of these areas in more detail, definitely let us know. Make sure to follow us for more deep dives. Thanks so much for tuning in.